So far with solving systems of equations, you guys have learned the substitution route. Substitution always works, but sometimes there is a more efficient way. Today we are going to use some of the examples from What Kind of Shoes Does a Frog Wear? I'm going to get you started, and then you can go off on your own. The one thing I would suggest is making sure you have a pencil and a colored pen or pencil or something just different, just to kind of help you get used to the negatives and how you can swap the signs of things and make sure you're keeping up with all of the integer changes. So we're going to go ahead and start with number 1. Each and every time you're doing one of these, you need to rewrite and stay organized. That's going to be something I'm going to hold you accountable for. 5x minus 2y equals 4, and then the other equation is x plus 2y equals 8. The method we're going to use today is called elimination. We are trying to literally eliminate one of the variables. In a sense, you did it through substitution because you substituted the value of one variable that was in terms of the other, so it eliminated the second variable. In this case, your goal is to eliminate either the x's or the y's, and it does not matter which one. You have to become savvy in figuring out which would make the most sense. So for instance, if I look at this one, I see the minus 2y and plus 2y. Whenever I add those two things together, the y's cancel to 0y. So if I'm thinking about it, I'm going to add these together. I'm going to add down the line because I'm going to add my x's together. I have 5x plus 1x, which is 6x. Negative 2y plus 2y is 0y. So there are no y's. And that equals 4 plus 8, 12. From there, it's a simple single-step equation. Divide by 6, x equals 2. So in the grand scheme of things here, we are doing our solution as an ordered pair. I know my x value is 2, and then you can go back to either of these equations and plug 2 in. You need to show me that step. If I do 5, instead of writing x, I'm going to write 2. 5 times 2 minus 2y equals 4. I have 10 minus 2y equals 4. I'm going to minus 10 from both sides. That leaves me with negative 2y equals negative 6. Divide by negative 2, y equals 3. So I can come back up and plug that into here. You can always go back and make sure that your solution works. 2 plus 6 equals 8. So I know that I have a solution to my system. I'm going to skip to number 3, which I want you to do the same. You can come back and do number 2 on your own later. Number 2, I'm sorry, we're skipping 2. We're going right to 3. Number 3 is 3x plus y equals 13, and x plus y equals 3. Hopefully you notice here that you have 1y and 1y, and if we add those together, then we have 2y. If we add them together, we have 4x. We aren't able to eliminate the way they are right now, but you have the option of making everything is negative. So technically what I'm doing here is I'm multiplying by negative 1. So I'm multiplying this entire second equation by negative 1. It's just like if I have, 2 plus 3 equals 5. If I multiply everything by negative 1, negative 2 plus negative 3 still equals negative 5. Every term gets multiplied. So I'm going to come rewrite this. So I have 3x plus y equals 13. Then I have negative x plus negative y equals negative 3. I'm going to add my two equations together again. 3x plus negative 1x is 2x. Y plus negative y, whoop, they cancel, equals 13 plus negative 3 or 10. Divide by 2. Divide by 2. X equals 5. So far, my solution is 5 something. Go back to the original equation. Don't go back to where you have changed it. And use the easier of the two equations. So in this equation, I have x plus y equals 3. So I would just have 5 plus y equals 3. minusing 5 from both sides leaves me with negative 2, which is more y. Use this on your first equation and just make sure it works. 3 times 5 is 15. 15 plus negative 2 is 13. So this is where those two equations would intersect. I am going to move on to number 6. I have 7x minus 4y equals 10. Sorry, negative 10. And then they give me 4y equals x minus 2. You have options here. You almost have y by itself, so you could divide both sides by 4 on this equation and then plug in and substitute for y, but that doesn't make as much sense because I see a positive 4y and a negative 4y, so I know that those are going to be two values that I can cancel out. In order to do that, I need to make my equations look more similar. So I'm going to rewrite my first equation into that standard form. And then I'm going to actually rewrite my second equation to look just like the first one. So I have negative x, that'd be plus 4y equals negative 2. Okay, you could even move this 7x over to the other side, and then you would have gotten 0, but that would have been fine. You could still solve for x. Negative 4y plus 4y, those cancel. So I have 7 plus negative 1x is 6x. Negative 10 plus negative 2 is negative 12. Divide by 6 on both sides. X equals negative 2. So I have negative 2 so far. I got to solve for my y. And I'm going to come to the second equation. Just looks a little bit easier. 4y equals, instead of writing x, I'm going to write negative 2 minus 2. 4y equals negative 4. When I divide by 4, y equals negative 1. And that should be my solution. I can go back to the first equation and just make sure. 7 times negative 2 is negative 14. Negative 14 minus 4 times negative 1 is negative 4. Does that equal negative 10? Negative 14 plus 4 is negative 10. Whoops, I'm sorry, you guys couldn't see that. So I know that I have the solution. I'm actually going to skip to number 9. We're not going to finish it together, but I'll show you how you can not have to rewrite it all the time. So number 9 they have written as x plus 2y equals negative 2. 4x plus 2y equals negative 17. This is where I'm seeing plus 5 plus 2y. If I add them, I get 4y. I don't want 4, I want 0. You can also cancel your x's out. That's also an option. In this case, it makes more sense to cancel my y's. So I am going to make everything in this second equation it's negative, and I'm just going to use my separate color to show that. I'm going to do negative 4x, negative 2y, and then positive 17, and then I can add them. And then you can go from there and solve for x.